Okay, good evening. So we are here to review the 3 papers in MCQ Intensive 3. So we'll start with the first paper, Presbyterian High. So please mark your work as I write the answers down. So these are the answers to the 20 questions in the Presbyterian High School paper. So please mark your work. And once you're done, please ensure you write the correct answer if you have gotten it wrong. And if you have finished scoring your work, please also write on the cover page what you scored out of 20 marks for Presbyterian High. And once you have finished marking, doing corrections, and scoring your work, please give me a thumbs up so that I know that I can move on. Okay, so I believe you have already marked your paper. So let's go through a few questions. Let's start with question number 1. Now, question number 1 it might look a bit strange to some of you who are new to this, but the keyword here really that you should be highlighting in an exam is water-cooled condenser. So basically, this helps to cool and condense the vapor, right? So it's water-cooled. Now, this water refers to tap water. You basically switch on the tap. So this is clearly water at room temperature. Room temperature is 25 degrees Celsius. So for it to condense the substance is a liquid at 25 degrees Celsius. Now, this is really crucial. You must realize the concept is about the substance being a liquid at 25 degrees Celsius. So now you look through A, B, C, D. Which substance has a boiling point and a melting point, which allows it to be a liquid at 25 degrees Celsius? I think it's quite clear-cut. The only one possible would be B. All right. So B is the only substance that will be a liquid at 25 degrees Celsius. Next, question 2. Most of you probably still got question 2 correct, but can I please encourage all of us to highlight numbers with their units? Now, this is really crucial. By highlighting the numbers with the units, you will realize that, okay, there's 1 grams. 1 grams is mass. 10 cm cube is volume. In this case, volume of acid. Next, you need to focus on words like different temperatures. Temperature. Finally, she measures how long it takes. That's time. All right. So there are 4 different variables that she's measuring here: mass, volume of acid, temperature, and time. So in order to measure these 4 variables, you will need a balance. You will need a clock or stopwatch. You will also need to measure 10 cm cube, either a burette or, in this case, not so accurate, measuring cylinder helps you measure volume of acid, approximately. Finally, the different temperatures will require thermometer to measure them. All right, so close reading and highlighting makes a difference, and it ensures that you do not make careless mistakes to do with misreading. All right. Now, question number 3, I think most of you would have gotten it correct. The answer is A. Both P3 minus and K plus will have an electronic configuration of 288. Now, question 4, I think some of you may still be confused about how to interpret particle diagrams to differentiate between elements, compounds, and mixtures. So please remember, compounds must be joined together. So this is a compound. This highlighted in yellow is a compound. So these are molecules of compounds. There is another compound in D, highlighted in blue. So what you notice is that the compound highlighted in yellow and the compound highlighted in blue, they are not joined. Therefore, we know this is a mixture ultimately, because the two compounds are not chemically combined together in a fixed ratio. So D is a mixture because the two compounds are not chemically combined together in a fixed ratio. Okay, and that was question 4. So we've completed the first page of questions. Now we move on to question 5. Now question 5 shouldn't be difficult in this case, because in this case, they have given you relatively easy options. You know that when you heat up a gas like nitrogen, it expands. So when something expands, what happens during expansion is the particles move further apart. All right, that's what causes expansion. Particles move further apart. Now, besides that, because you are heating up the gas, the particles gain kinetic energy due to the heating, and so they move more quickly. So this is quite straightforward. However, can I please encourage all of us to write down, during expansion, the spacing increases. So what we just mentioned just now about the particles moving further apart, the spacing between the particles increases. However, the size of the particles, in this case, the size of the nitrogen molecules, remains the same. Okay, so please take note, there is a difference. During expansion, the spacing does increase. However, the size of the particles will remain the same. Okay, the particles do not become bigger or smaller. That's for question 5. Now, this falls under the chapter on kinetic particle theory. So if you have forgotten what goes on behind explosion, please go and revise kinetic particle theory. Now, question 6 is not difficult. I'm sure all of you realized after some time what is the dot and cross diagram for carbon dioxide. It's A. Now, can I please encourage all of us to not choose based on intuition, to just glance at a diagram. Really ensure that you look at every single diagram carefully. All right? You don't want to be missing something out. Now, a common mistake that students will make is to choose C or D for such a question. Why would they choose C? Now, they would choose C if they did not pay attention to the symbols of the elements. It's CO2, 1 carbon, 2 oxygens. So C cannot be the answer because C has 2 carbon atoms. That's incorrect. D is also a common mistake that students will make. They recognize that CO2 has a double bond, and therefore they focus on the dot cross, which is shared. However, they forgot that oxygen still has 4 valence electrons on each oxygen atom, which are not involved in bonding. So D is also a common mistake made by students. So please don't choose so quickly. Really look through every diagram carefully. Now, question 7, I don't think it's very, very difficult. It's quite straightforward. Just calculating MR. O2 should be 2 times 16, right? Therefore, it's 32, not 16. That is question number 7. Okay? Now, question 8, I would like you to learn this well. Now, you're told in question 8, the water in the lake is acidic. The water is acidic, and that causes the fish to be dying. The water in the lake needs to be neutralized. All right, so what could neutralize the acid? Now, the key word here is not just about neutralizing the acid. They are asking you which compound can be added in excess to neutralize the water in the lake. This is a very important phrase you must pay attention to in this question. Now, why is that so? The common mistake for most students is to recognize the word neutralization and therefore choose the alkali, which is sodium hydroxide. However, that's wrong. Sodium hydroxide is not the answer to this question because when added in excess, the water becomes not neutral. The water becomes alkaline. If I add sodium hydroxide, a lot of it in excess, the water in the lake becomes alkaline, pH more than 7. And therefore, that will not be conducive for the survival of the fish, the plants in the water. So C, sodium hydroxide, cannot be the answer because over here, they want the compound to be added in excess. And that's why the answer ended up being A. Because you can add calcium carbonate in excess to neutralize the acid. Calcium carbonate reacts with the acid to form the salt, water, and carbon dioxide gas. So the products of the calcium carbonate reaction will be non-alkaline, non-acidic. The products are neutral. And that's why A is the answer. So if you got this wrong, it's probably because you had forgotten to pay attention to the phrase in excess. So in excess cannot be adding the alkaline substance. Okay, question 9, below it, is also about pH. I think this is quite straightforward. At what point was the soil neutral? Neutral is pH 7. Therefore, B is the answer. All right. So that's question 8 and 9 about acids and bases, testing you on the concept of reactions, neutralization, as well as pH values. Now, question number 10 is a common question type for combined science. They will give you blanks and they ask you to find words to fill in and complete the statements. So first, the first blank, what can be used to prepare insoluble salts? Insoluble salts must only be prepared by precipitation. So precipitation is the method to prepare insoluble salts. Such as what? So what is insoluble? Definitely not barium nitrate. Nitrates are all soluble. So the insoluble salts such as lead 2 sulfate. Now, because it's insoluble, it will be a solid precipitate. So it's collected by filtration, then washed and dried. So the answer is C for question 10. It's on salt prep. Okay, so you must be very familiar with the different methods of salt preparation. Okay, so I think we move on to question 11. Now, question 11 is quite challenging. Okay, it requires you to analyze based on the information what Y and X could be. So you're told a compound X, please highlight, a compound X, when heated with aqueous compound Y, it produces a gas that turns red litmus paper blue. Now this is ammonia gas. So I'm sure you recognize the gas was ammonia gas. Ammonia gas was released when X was heated with Y. Take note, there is no aluminium foil. If there's no aluminium foil, there is no test for nitrates. So cannot be a nitrate. So statement 2 cannot be correct because there is no aluminum foil. If there's no aluminum foil, there's no test for nitrate in this case. Therefore, the only possible answers would clearly be the tests for ammonium. And to test for ammonium ions, we need to heat the ammonium compound with a base like sodium hydroxide. So the test for ammonium, if you recall, was to add aqueous sodium hydroxide and warm it. All right, so the answer will be 1 and 3. So this requires you to have good knowledge of the QA test for ions as well as gases, okay, and use the information to deduce correctly what X and Y could be. Okay, that's question 11. So I hope you learned this well. It's a good way to test QA as well. Question 12, I think is quite straightforward, but please do not miss this sentence. Dissolving potassium chloride in water is endothermic. So endo, it enters. So what enters? Energy is taken in, or energy is absorbed. So A or B. Next, if it's endo, the temperature decreases. It becomes colder. All right. Another way to say temperature decreases, it means that it becomes colder. Next, if it becomes colder, we say the temperature change is negative. Temperature change is negative. What does this mean? It's negative temperature change when the final temperature is less than initial temperature. So that's why when we take the final minus the initial temperature, it's a negative number. All right, so please know this. Endothermic change means energy is taken in from the surroundings. Temperature change decreases, the temperature decreases, and it becomes colder, and the temperature change is negative because the final temperature is less than the initial temperature. Now, this is a common question asked during the TYS as well. You will notice that there was a TYS question that was asked about, I think, every 3 years or so, 2015, 2018, where they showed you the temperature changes, plus 6.0, minus 10.0, and so on. So you need to know how to interpret. If the temperature change is negative, then the reaction is endothermic. Now, question 13. Now, question 13 is a classic question where it's very easy to be careless. Why is it very easy to be careless in question 13? It's because they want the statement which is not correct. That means out of the 4 options, 3 are true, 1 is false. They want you to choose the one which is false. And to do that, you got to read statement by statement. So I'm sure most of you knew that B is correct, C is correct. These are quite obvious. If you have revised the blast furnace, hematite is the iron ore, contains iron 3 oxide. Hot air contains oxygen for the burning. Now, A is also true. Coke burns in hot air. We know that. Coke burns in hot air, the oxygen in hot air to form carbon dioxide. Now, this reaction produces carbon dioxide, which is again needed to produce carbon monoxide, right? Which is the reducing agent for the blast furnace. So this reaction is needed to produce CO2. The CO2 then reacts with excess coke to produce CO, which is the main reducing agent in the blast furnace. However, many students will be confused at the second part. Does this produce a high temperature? And the answer is yes. Why does the burning of coke, C plus O2 form CO2, produce a high temperature? This is because combustion is exothermic. So you have learned a few exothermic reactions. Neutralization is exothermic. Combustion is another common typical reaction, which is exothermic. All right, so you know this reaction must release heat energy to the surroundings, causing the temperature to rise. So A is a true statement, it's a correct statement. So only D is false. And of course, I'm sure you can recognize what's so false about it. Limestone is not the reducing agent. The reducing agent is carbon monoxide, CO. CO is the main reducing agent for the blast furnace. All right. So that's question 13. The skill here is really to read every single word to ensure that you have chosen the correct option. Okay. And now we'll move on to question number 14. Now, question 14, you must know the reaction. Hydrogen will form water when passed over the heated oxides of P and Q. What kind of reaction can this be? So, for example, this is the reaction. H2 plus the oxide of P, PO, forms P and H2O. So what has actually happened? What has actually happened is that hydrogen reduces P from its oxide. Hydrogen can reduce P from its oxide. At first, P was together with oxygen. Now P is on its own. Similarly, hydrogen is also able to do the same thing to Q. That's what the question said. So we can say that hydrogen reduces Q from its oxide. All right. So both P and Q can be reduced by hydrogen. Now, if it can be reduced by hydrogen, it means that P and Q are not the most reactive metals. Only metals that are not so reactive, like copper, silver, lead, can be reduced by hydrogen. All right. On the other hand, no reaction with the oxide of R. Not reduced. If it's not reduced, it means R is very reactive. R is a very reactive metal, and hence it forms a very stable oxide. That forms a compound with it, R is not going to let it go. R is not going to go back without oxygen. So R is very reactive. So if R is the most reactive, putting the most reactive listed first as the most reactive. Then we go on to the next line. Furthermore, Q reduces the oxide of P. What does this even mean? Q, metal Q, plus PO becomes QO plus P. So another way to put this is Q displaces. It's a displacement, right? Q displaces P from PO. So if Q can displace P, Q is more reactive than P. And that's why the answer is B. Now, you need to know this really well because I think most students are not familiar with this concept of reduction of the metal from its oxide. If the metal can be reduced, it's not very reactive. On the other hand, if the metal cannot be reduced, like R in this case, cannot be reduced, that means it's super reactive. All right? If there's one question you need to learn from this, this is the question. All right? Now, the remainder of the questions, you have the answers already. I think I shall not be going through the remainder of the questions. All right? So please look through the remainder of the questions yourself. So now let's move on to the next paper, the JYSS paper. Okay, so here are the answers for the JYSS paper. So as mentioned, I think the JYSS paper might actually be slightly challenging in many ways. In many questions, it's quite tricky or there's a lot to be read. So let's go through the questions and learn the skills behind every single question. So question number 1. So you notice the first question is usually about selecting apparatus or about gas collection methods. So you need to be familiar with how to select apparatus for experiments, as well as how to collect gases using the 3 different methods that we have learned. So please revise chapter 2, experimental techniques, if you have not. If you are not familiar with the gas collection methods, you must be familiar with them. All right. So the way to do these kind of questions on selecting apparatus is to pay close attention to what they want. So as you can see, I've highlighted several key phrases which tells you what they want. First, you want to find out how fast. How fast is speed or time? Time taken. Next, your magnesium ribbon needs to be 3 cm in length. Thirdly, you want 10 cm³ of sulfuric acid. That's volume of acid. Finally, different temperatures. So this is quite similar to just now Presbyterian High School, the paper. So once you have paid attention to this, you will know that you definitely need a measuring cylinder for the volume. All right. You will need a stopwatch for time. And you need a thermometer for temperatures. So you're only left with the apparatus not needed as the electronic balance. Now in question number 2 is about samples from 2 river sources X and Y. They are analyzed using chromatography with a suitable solvent. Now this is the result. The chromatogram is the result. So you look at the chromatogram, immediately you are hit by the realization that Fe2+ remained on the starting line. If Fe2+ remained on the starting line, this means it's insoluble, right? So clearly, which statement is not correct? Quite clearly, A is not correct because Fe2+ is not soluble. It remained on the starting line, therefore it's not soluble. All right. Now, B, C, and D are all correct. Okay, I'm sure you can see why B is correct because both X and Y contain more than one component, which can be separated by chromatography. So if it can be separated by chromatography into more than one component, it's definitely a mixture. It's definitely impure. All right, impure in this case refers to it being a mixture. Next, sample X contains one unknown substance. So what is this unknown? Well, this unknown substance is the spot that I've highlighted in green. This spot highlighted in green does not have the same height as any of the metal ions. Therefore, it's an unknown substance. And finally, Y does contain copper, nickel, and lead ions. All right? It has the spots corresponding to the heights of these 3 ions. So for question 2, the answer is A. Then we go to question 3. Now, question 3 you will see in the Pure Chem papers. However, it's also in the combined science syllabus. So the following setup is used to obtain ethanol from a solution of ethanol in water. So it's ethanol and water. You are told ethanol boils at 78 degrees Celsius. Water, you should also write down, boils at 100 degrees Celsius. All right. Now, once you have written the boiling points down, it becomes obvious that this is fractional distillation. It's fractional distillation because both of the liquids are miscible and they have different boiling points. All right. Now, because they have different boiling points, they're separated by fractional distillation. Now, the key thing to note here is if you know it's fractional distillation, you now need to work out which liquid will boil off and distill out first. So ethanol will boil and distill out first because it has a lower boiling point of 78 degrees Celsius. So these annotations that are written down are crucial. You need to write these annotations down. Without these annotations, you are going to get it wrong. And that's why I keep saying, if your MCQ paper is completely clean, there are no annotations, no underlining, no circling, something is wrong. Something is gravely wrong if the whole question is clean. You need to be writing things out like what I'm doing. So once you realize that ethanol is the one that boils and distills out first, what will the concentration of ethanol in the boiling flask, which is this? How will the concentration of ethanol in the original boiling flask change? Once you know that ethanol boils off first, if it boils off, the ethanol is gone. The ethanol is removed by boiling, right? So the answer is C. The concentration of ethanol in the boiling flask must decrease because it's boiling out. It's boiling and distilling out first. And why will ethanol distill out first? Is because the boiling point is lower than water. So please learn this well. Now this is for ethanol because ethanol has a lower boiling point than water. Okay? Not everything has a lower boiling point than water. So now let me give you another example. All right, I'm going to give you another example of a liquid as well, which has a different boiling point from ethanol. Okay, so I'm going to give you the example of butanoic acid. Now, butanoic acid has a boiling point of 165 degrees Celsius. All right. So if I have butanoic acid in water, and now Mr. So were to perform fractional distillation on this mixture, butanoic acid in water. If you look at the boiling points now, what will distill out first? If you look at the boiling points, I think it's immediately obvious to you. Water at a boiling point of 100 degrees Celsius will distill out first. Because now, water as compared to butanoic acid has a lower boiling point. So, water will distill out first. So, how will the concentration of butanoic acid change with time? So just now, ethanol decreased with time, right? Because ethanol boils first. But now it's the reverse situation. It's the water that's boiling out first, meaning the water is slowly boiling away. If the water is boiling away, the water is being removed, the concentration of the butanoic acid will go up. So now please compare and contrast the two different scenarios. One with ethanol, which has a lower boiling point, and now with butanoic acid with a higher boiling point. So learn these two scenarios, they are different. So can you please copy down the scenario with butanoic acid now? Okay, moving on to question 4. Now question 4 is about the heating curve. So I'm sure you realize Q and R is where melting takes place. Now, during melting, boiling, when it's change of state, the energy gain is not used to increase the kinetic energy. The energy gain is used entirely to overcome forces of attraction. So this is Q and R, C. All right. Now we move to question 5. Now question 5 again is about KPT. Bromine melts at -7, boils at 59. Please use a number line to represent the melting and the boiling point. It's crucial that you do this. Do not assume your math is good. You can do mental arithmetic. Nope. You need to draw the number line out, and then after which you label solid, liquid, gas. All right, this is very important. So now you are given two temperatures. A tank filled with bromine at 30 degrees Celsius is cooled to -10. So now let's label. Where is 30? 30 is here, meaning it's a liquid. because it falls in the L region of the number line, liquid. Where is minus 10? Minus 10 is less than minus 7. If it's less, it will be on the left-hand side. Minus 10 is a solid. So now, basically, I'm looking out for solid, liquid. Solid and liquid is best expressed using B. All right. Now, you might be wondering what on earth is X, right? X, you can see this part is liquid. This part is solid. So X represents solid and liquid together. Now, when will you have solid and liquid together? You have solid and liquid together when it's at the melting point. So X represents the arrangement of the particles at the melting point. Because during the melting point, during melting, you have both solid and liquid state. All right. Now moving on from question 5, once you're done. Okay, we go to question 6. Now, question 6 is a typical combined science question where they go through different pieces of information that you need to analyze to work out whether something is an element, compound, or mixture. So let's go to question 6. They have given you information about X and Y. Now, when X is burnt in oxygen, carbon dioxide and water vapor are formed. You got two things formed, CO2, H2O. If you form two different products after burning in oxygen, it means that X is a compound. All right, X is a compound because it needs to have both carbon and hydrogen inside X, or else it will not be able to form both carbon dioxide and water. Next, Y. It melts over a range of temperatures. This tells you Y is a mixture. Because if it melts over a range of temperatures, it's impure. So remember, how do you tell if something is impure or pure? Is to look at the melting and boiling point. So you will arrive at the answer A. X is a compound, Y is a mixture. Now, question 7. Question 7 is now a very typical question type that you will find in many other schools' papers. They give you two statements and ask you, oh, are the two statements correct? Do they explain each other? Or are the statements incorrect? So you have to read the statements thoroughly. Every single word must be read. So the first statement, potassium iodide, consists of atoms arranged in a lattice structure. So this statement 1 sounds attractive, sounds logical, because you have learned giant ionic lattice structure. You might have heard of it. You might have seen lattice in your notes, right? Indeed, potassium iodide is an ionic compound, so it has giant ionic lattice structure. So since it's ionic, it's not atoms, it's ions. So because one word is wrong, the whole statement is now wrong. So statement 1 is incorrect because potassium iodide consists of ions arranged in a lattice. So statement 1 is wrong. Statement 2, solid potassium iodide needs to be dissolved in water first to be able to conduct electricity. This is correct, because you know that ionic compounds will conduct when in the aqueous and molten states. So the answer is D. Statement 1 is incorrect, but statement 2 is correct. All right, so the learning point from question 7 is please read thoroughly. It's really crucial. Okay, and please be very careful with the way the questions use words like atoms, ions, and molecules. So we have gone through in class the difference between atoms, ions, and molecules. So I hope you still remember that. Okay. So now moving on to question 8. Now I think question 8 is quite straightforward. If you are familiar with chemical formula, you're told it's Hg2+. The charge is 2+, right? So you must think,
what is the charge on the N ions? Well, in this case, it's carbonate in A. Carbonate is CO3 2-, meaning the formula should not be this. The formula just has one carbonate ion, right? HgCO3. Next, you have OH-. So the formula should be Hg bracket OH2. So again, B is wrong. C is correct because it's NO3-. So nitrate only has a 1- charge, so you need 2 nitrates in order to balance out the 2+ charge. Finally, D is wrong. The formula for mercury 2 sulfate is HgSO4. So the answer is C for question 8. So if you've got question 8 wrong, it means that we have to revise the formula of ions like carbonate, sulfate, nitrate, hydroxide. Then we move to question 9. Now, question 9 is quite clearly mole concept. In mole concept, you need to use working. If you don't use working, this is when you will make loads of mistakes. So please, I encourage all of us tomorrow to make full use of the time given to us to do working. If you do working, you will realize that the first part, you need to convert 21 grams to moles. That's the first step in mole concept. Converting the quantities to moles. 21 grams divided by mR, that gives you 0.25 moles. The next step is mole ratio. Please write it out. I want to find magnesium oxide. The mole ratio is 1:1. So 0.25 mole to 0.25 moles. So I also form 0.25 moles of magnesium oxide. And now the mass is just 0.25 times the MR, 24 plus 16, that gives me 10 grams. So the answer is C. Now, this question is really simple. They have given you a really simple equation where everything is in a 1:1 ratio. However, for combined science, express combined science, they are very unlikely to give this. They are very likely to instead give you something where the mole ratio is not 1:1. This is the reason why doing working is so important. The second question illustrates that really well. If you did not do working clearly, you wouldn't even understand what question 10 means. So what does question 10 literally mean? It's really long, so let's read together. There are 2 titration experiments. This is crucial. This means that the 2 titrations are not linked, they are not the same, they are not performed in the same conical flask at the same time, right? So 2 different titrations to find out volumes of acid needed to neutralize 20 cm³ of 0.1 mole per dm³ sodium hydroxide. The first thing you should do is to now convert this volume and this concentration to moles. It is 0.002 moles of sodium hydroxide. All right. The next thing you need to take note of in the next paragraph is that the acids are hydrochloric and sulfuric acid, and both of them have the same concentration. If you miss this out, you will not understand the question. Both the hydrochloric acid and sulfuric acid have the same concentration. All right. And so here they have helped you by giving you the equation. What's the purpose of the 2 equations? Well, you are told that reaction 1 is with HCl, and you are told reaction 1 required 25 cm³ of HCl. So what can I use this to do? I now need to find the concentration of the acid. Now, why is it so important to find concentration of the acid? Because you are told that both the hydrochloric and sulfuric acid are at the same concentration. So by finding concentration of one acid, you have found the concentration of the other acid as well. I need this. If I don't have the concentration, I will not be able to find the answer for the volume of sulfuric acid later. So how do we do this? Mole ratio of NaOH to HCl, 1:1. So 0.002 moles of NaOH is to 0.002 moles of HCl. So what is the concentration of HCl? So this is where we use the formula triangle NCV. C is N over V. And that gives me 0.08 moles per dm cube. All right, so the concentration of HCl we calculate using the data given to us for experiment 1 is 0.08 mole per dm cube. Now what this means is that the concentration of H2SO4 is also 0.08 because you are told that both acids are of the same concentration. Then now we will do the same analysis, but this time round is for experiment 2. Experiment 2 uses NaOH and H2SO4. 2:1. NaOH is still 0.002 moles because you use the same volume of alkali, sorry. And the acid is 0.001 moles. So what is the volume of H2SO4, which you want to find? So it's N over C, 0.001 over the concentration is 0.08, and that gives you 0.0125 dm cube. If you convert to cm cube, 12.5 A. All right. Now this is a multi-step problem. As you can see, if you just leave the numbers in your calculator without writing out the working, you are almost guaranteed to get it wrong. So you got to ask yourself, if you have 1 hour to do the MCQs, shouldn't you do working? And shouldn't you present your working clearly like this? You should maximize your chances of getting things correct. And the way to do so is to highlight, underline, annotate, write working, especially for mole concept. Another advantage of writing working is that when you have extra time left at the end, let's say you finished it 15 minutes early, then you have time to come back and check. And as you check, if you have done working, you actually understand what you were thinking, what you were doing. If there's no working, if it's all blank and clean, you will need to redo the problem, which is much, much more wasteful in terms of time. Okay, so I do not want to see any of you leave this question without working. So once you have finished copying down this working, can you please give me a thumbs up so that I know you're done? Okay, now moving on to question 11. Now question 11 also happens to be one of those questions where there is a lot to be read. So whenever you are dealt with a wall of text like paragraphs, you will need to analyze it slowly by underlining the keywords. The keywords usually have to do with the chemical names, have to do with the numbers, right? Okay, so can I please encourage all of us to highlight chemical names and numbers? Now, numbers need not just be 0, 1, 2, 3. Numbers can also be things like this. Okay, words like limiting, excess have to be paid attention to. And this is really crucial. Once you know it's sodium hydroxide to hydrochloric acid, the reaction is neutralization. Neutralization is exothermic. You know that from your revision. Neutralization is very exothermic. All right. Now, the issue here is the alkali was added in excess. All right. So the alkali is in excess. So what that means is that the neutralization actually ended before the
end of the experiment. I added alkali until it was in excess, meaning the neutralization was completed even before the end of the experiment. That means the neutralization has completed way before 180 seconds. All right. So now they ask you, which row shows the possible temperatures of the reaction mixture? Firstly, you know it's exothermic. Exothermic, the temperature goes up, increases. Temperature increases. So definitely A wrong, B wrong. A and B are definitely wrong because they show that the temperature is decreasing. But instead, the temperature should increase, go up. So it's either C or D. So you look at C or D, what's the difference? The difference, of course, is this. If you look at the last three values of temperature, D shows the temperature going back down. C shows the temperature remaining at 45. Which one is correct? C, that remains high, is wrong. This is not correct. Why is this not correct? When the reaction ends, the mixture should cool back to room temperature. It cannot remain high forever. It should not remain high at 45 degrees Celsius. After the reaction ends, the mixture will have no more reaction. It has to cool slowly back to room temperature, which is shown in D. It's cooling slowly back. So what does the graph actually look like? The temperature, time, it will go up to a maximum and slowly come back down. So this graph is shown in your energy changes notes. You need to be familiar with the shape of this graph. This is exothermic, so the temperature goes up and then drops back down slowly and cools back to room temperature. It cannot remain high forever. So please be very mindful of this. It's a very good and very common combined science question. All right. So question 12. Question 12, you can see we are reacting excess marble chips with HCl. So this is measuring the mass on the electronic balance. So how does the mass actually change? The mass decreases, right? But why does the mass decrease in this experiment? The mass decreases because the CO2 gas forms escapes. This is important. The mass decreases because the gas that's formed escapes from the flask. It's not because of other reasons. It must be because the gas escapes. That's why the mass goes down. Go down means A wrong, C wrong. But what's the difference between B and D? Well, D ends off before 0. B ends off at 0. And of course, this is again not correct. B is not correct because mass cannot drop to 0. The mass measured cannot drop to 0 grams. So B is definitely wrong. The answer must be D. Okay, so please take note of this. Please be very, very mindful. Okay, I think the rest of the questions are fine, but let's just go straight to question number 18, all right, for me to explain very quickly. Now, question 18 is about an experiment to show the composition of air. Composition means, in this case, what gases make up air. So the volume of air is 100 cm³ at the start. There are reactants to remove CO2, reactants to remove oxygen, right? Oxygen is about 21% of air. So 100 cm cube should contain roughly 21 cm cube of oxygen, meaning what's left should just be about 79 cm cube. There is no 79 in the table though. So what do? Do you leave it blank just because you don't see 79 in the table? You know that it must be 79 because the air left must be 100 minus 21 equals 79. But there's no 79 in the table. Don't leave it blank. This is obviously rounding off. 79 is rounded off to 80. So the answer must be 80 cm cube of air left because only about 21 cm cube of the oxygen was removed. So 80 cm cube-ish is left. Now, what is the composition of this 80 cm cube? Is it just nitrogen on its own? Okay, obviously not. Okay, there are many gases in air. So there's nitrogen and there's other gases. And what is this other gases? What can these other gases be? The other major component of air is, of course, argon. So this gas that's collected in the tube in the water contains nitrogen and argon. Okay, so don't leave it blank just because you don't see 79. It's obviously due to rounding off that they chose to give the volume as 80. And Cambridge might actually do this when setting the paper as well. So be mindful, be adaptable, choose the best answer. Okay, now as mentioned for question number 20, I told you that you don't have to do this because JYSS taught one more reaction which is not in the combined science syllabus. The answer for question 20 is B. Okay, but let me just expose you. How does this work? So first we have ethene. All right. So alkenes, you have learned you can add hydrogen, you can add bromine to it. However, you can also add steam to it. By adding steam to ethene, what you form is this. The double bond breaks, and then it forms the alcohol. So ethene is able to form ethanol by reacting it with steam. All right. So this is the first step. The second step is how do you convert ethanol to ethanoic acid? So this you ought to know. This is in your syllabus, the second step. The second step to convert ethanol to ethanoic acid is, of course, oxidation. And to oxidize ethanol, we use acidified potassium manganate 7. All right. So that's why there are two steps here. The first step is conversion of the alkene to the alcohol by reacting with steam. It's the addition of steam to form the alcohol. And the second step is the oxidation. Using acidified KMNO4 oxidizes the alcohol to the carboxylic acid. Okay? But the first step is actually not in your syllabus, so I don't think you will need to memorize it. Okay, so just for your exposure. Okay, moving on to the next paper, which is the last paper already. It's the Fairfield Methodist paper. I'm just going to give you the answers, and then we'll mark our work. Okay, the Fairfield Methodist School paper. Let's start marking. Okay, let's skip the physics questions. Okay, I'm going to be giving the answers on this page, so just take note. Okay, it starts from question 21 because question 1 to 20 was physics. Okay, so please mark The Fairfield method is 20 questions. And again, please let me know your scores in the chat. Please type your scores to me, all right? So for this last paper, please take note, okay, the question 30, the answer should be A as highlighted in yellow. So please look at this set of answers while marking. Okay, for this paper, I'm not going to go through every single question. All right, I'll just jump straight to question number 27. So let's go to question 27. Now, I mentioned to you this in class many times. Question 27 is a clear-cut limiting reactant question. You must be able to do this yourself. All right. So 100 cm cube of nitrogen. 100 cm cube of nitrogen. Nitrogen is a gas. There is no need to convert it to moles. Just compare the volumes. If it's 100 cm cube of nitrogen, all right, then you look. The hydrogen is 3 times of it. So 300 cm cube of hydrogen needed. So 100 cm cube of nitrogen only requires 300 cm cube of hydrogen. But I'm given 400 cm cube of hydrogen. This means that I have 400 minus 300, 100 cm cube of hydrogen left. It's left in excess. All right, this is important for us to take note. Next, how many cm cube of NH3 ammonia will be formed? Well, it's 1:2, so it's 200. So I have 200 cm cube of ammonia formed because the ratio is 1:2, 1 and 2 to 2 NH3, 100 and 2 to 200 NH3. So I have 200 cm cube of ammonia. But is that the answer? Is that the total volume of gas present? Remember, you still have 100 cm cube of hydrogen. The excess hydrogen is left behind. You must add 200 plus 100 is 300. All right. So the answer is 300 cm cube for question 27. You need to be able to do this yourself. This is a classic limiting reactant question. Okay, so please learn this well yourself. If you have done enough practice, you would also have seen this in a very large number of prelim papers. Okay, so never ever forget the excess gaseous reactant, in this case, the excess hydrogen left behind. And now let's go to question 29. So 10 cm cube of hydrogen peroxide of concentration 0.4 moles per dm cube was decomposed into oxygen gas and water at 30 degrees Celsius. So you're measuring the volume of oxygen gas in this case. And you notice you did a second experiment. Graph 2 shows the second experiment. Immediately start annotating. The second experiment is slower. How do you know the second experiment is slower? You know that it's slower based on the gradient, right? The gradient for number 2 is less steep. So because it's the less steep gradient, it's a slower reaction. So what will cause number 2 to be slower? Clearly, it cannot be a higher concentration or the same concentration. So clearly B is out. B is out because it has the same concentration of hydrogen peroxide, same temperature. So that will not result in a slower reaction. Another option, which also has to be eliminated now, D. D is definitely wrong as well, because the temperature is higher. If the temperature is higher, the reaction should be faster, not slower, right? So B, out. D, also out. So you are just left with A and C. So now, what do you analyze? Remember, in every speed of reaction graph, we analyze the gradients first. The gradient is the speed. The next part is the final volume of gas. In 2, the final volume of gas is larger. So what is the final volume of gas dependent on? This is dependent on the number of moles of the limiting reactant H2O2. All right, so now we got to calculate moles. How do we do that? We got volume, we have concentration, and CV. All right, N equals to C times V. So this is the number of moles of hydrogen peroxide. So in experiment 1, we have 0.004 moles of hydrogen peroxide. Now, we're going to work out for A and C, what are their number of moles of hydrogen peroxide. So this will give me 0.0025 moles. If you compare 0.0025 in A versus the original 0.004, this will be wrong. This is lower, but you look at the final volume of gas is higher. So now clearly it cannot be this, it must be C. So you need to do mole concept calculations as well in this question to prove that the answer is C because it has a larger number of moles of hydrogen peroxide. Okay? So that's question number 29 about speed of reaction graphs. Remember the two portions. The gradient tells you the speed, and the volume of gas at the end, the final volume, tells you the number of moles of hydrogen peroxide. All right, let's go to question 32. You're told that samples of 3 oxides, FGH, are added separately to dilute hydrochloric acid and dilute sodium hydroxide. Importantly, F reacts with acid. G also reacts with the acid. H doesn't react. If H doesn't react, H is basic. Oh, sorry, acidic. If it doesn't react with acid, this means that H itself must also be an acid. So A, wrong. B, wrong. So you're left with C and D only. All right, then you continue to read. G and H. G and H react with sodium hydroxide, but F doesn't react. So if F doesn't react, F is basic. All right, because bases don't react with other bases. So F is basic, H is acidic. The answer is D for this question. Okay, so you can see the importance of close reading. As you read, you annotate, you underline, you are really going to get the question correct. But if you fail to do that, you just want to finish it quickly without any annotations or underlining or working for mathematical sums, the chances of you making errors is quite high. And the errors will start to add up. If you make one error here, one error there, it could result in about 6 marks, 7 marks, 8 marks gone. And that's where you start to worry about your own scores. So don't do that. Make use of the time to do all these annotations, all this working. Okay? And the same is true for question 33. Question 33, I'm sure you will agree with me, is relatively straightforward and easy. The answer is B. Okay? But you need to read every sentence carefully. Firstly, you want the correct statement. So A, group 0 elements are unreactive metals. What's so wrong about this? It's wrong, but why? Which word makes it wrong? So if you read group 0 elements are unreactive, it's correct, but they are not metals. Group 0, they are all non-metals. They are all noble gases. Next, group 7 elements exist as single atoms. Also wrong. They are diatomic. molecules. Right? So like Cl2, F2, I2, group 7, they are all diatomic molecules. And finally, the last statement, the elements become more metallic moving from the left to the right. Wrong. They become less metallic. So if I were you, even though I know B is the answer, I will make use of the time given to write out why A, C, D are wrong. And this is what I notice many of you don't do. If you are able to write out why ACD is wrong, this tells you that you are convinced that B is right. And this really ensures that you don't choose the wrong thing. Okay, so can I please encourage all of us, if such a question comes out where they ask you to choose the correct statement or the incorrect statement, can you please also look at the other options and prove why are they wrong? Okay, it really ensures that you keep your careless mistakes to a minimum. Careless mistakes are not really careless. Careless mistakes are errors you make when you don't put your heart and soul into analyzing a question. Okay? And finally, let me go to question 36, and we will end off with 36 and 40. Question 36. Approximately 40% of all iron and steel is produced by recycling. So I'm sure you deduce that iron, when recycled, produces less CO2 than extracting it by the blast furnace. This is definitely true. 1 is definitely true, right? So C is wrong. 2. Scrap steel contains a higher percentage of iron than iron ore. All right. This is the one where it's most likely false. Now, why is that the case? Now, scrap steel is basically steel that's discarded. So firstly, steel is an alloy of iron and carbon. Next, because it's scrap steel, it's probably dirty, it's probably rusty. Hence, compared to iron ore, perhaps the percentage of iron may not be so high. All right. Moreover, the scrap steel is probably obtained from an appliance, an object, which is not just made of steel. Scrap steel probably contains other materials other than steel. Okay, take for example, scrap steel may come from your cars. Your cars also contain things like paint, plastic. So all this forms part of the scrap steel as well. So ultimately, scrap steel may not contain a higher percentage of iron. Number 3 is definitely correct. Scrap steel, if not recycled, would cause environmental problems because you have to find space to dispose of it in the landfills. So the answer for this is B. Okay, some of you might have chosen D. D is not correct. All right, the answer for question 36 is B. Now, moving on to question 37, I'll just give you the answer quickly. Question 37, the answer is D. Please remember that the homologous series, alkanes, alkenes, alcohols, and carboxylic acids, they undergo complete combustion. And when they do so, they form carbon dioxide and water only. All right, only. Now, let's move on to question 39. Now, question 39, I'll just quickly go through it. So this is the repeat unit. So if this is the repeat unit of the polymer, the monomer has the carbon-carbon double bond. So clearly, A is wrong. The monomer must have the carbon-carbon double bond. Next, C and D are also obviously so wrong because the monomer must have 2 carbons in the central chain in this case. The monomer is just B. Okay, so if you got this wrong, please go back to our alkenes notes and practice addition polymerization. Next, can you please write down the polymer? The polymer is saturated. The polymer has no double bonds. You can see that the polymer has no carbon-carbon double bonds. It's saturated. So the polymer does not decolorize aqueous bromine. So this is very, very important to know. Polymers do not decolorize aqueous bromine. On the other hand, the monomer is unsaturated.
the monomer has carbon-carbon double bonds, and hence it decolorizes aqueous bromine. And that's the difference between the monomer and the polymer. The monomer is unsaturated, it decolorizes aqueous bromine. The polymer is saturated and it does not decolorize aqueous bromine. All right. Ken, so question 39, you must know the difference between monomer and polymer. All right. And now let's end off with the final question. I will just take about 4 minutes, I think. Okay. So question 40. Okay, unfortunately, some of the alignment ran. Let me just draw the hydrogens in. All right. Now, the first thing you do when you receive an organic molecule like this, please highlight the functional groups or circle it, okay? You see basically 3 different functional groups. You see the carboxylic acid, you also see the alcohol, and finally, you also see the carbon-carbon double bond. Right? So this tells you that, okay, there's double bond. Double bond means decolorized aqueous bromine. Carboxylic acid means reacts with carbonates. The carbon-carbon double bond means it will undergo addition polymerization. Finally, the alcohol means it will undergo oxidation with acidified potassium manganate 7, and therefore the answer is D. If you did not choose D, it's either because you have forgotten about organic chem reactions, meaning please revise the organic chem summary, or you did not pay attention to all the functional groups present in the molecule. So please ensure you circle, underline, highlight the different functional groups in an organic molecule. It will really help ensure that you get all the homologous series, all the functional groups correct. Okay, and that's really the end of today's lesson. All right, I've gone through all the MCQs. Okay, thank you so much.